Level 0. The ceiling on Earth. The strongest storm this planet knows how to build. A hurricane is what happens when the ocean gets warm enough to start giving itself away. Above about 80 degrees Fahrenheit, tropical water evaporates in enormous volumes. That wet air rises, pressure drops at the surface, more air rushes in to fill the gap, and the rotation of the Earth sets the whole system spinning. Once sustained winds pass 74 miles an hour, it is officially a hurricane. A Category 5 starts at 157. 2015, Hurricane Patricia reached sustained winds of 215 miles an hour, the strongest ever recorded in the Western Hemisphere. These things are heat engines, and they are grotesquely efficient. A single hurricane releases energy equivalent to a 10 megaton nuclear bomb every 20 minutes. Quick thing before we leave the planet, if you are into this, subscribe, like, and drop a comment. It genuinely helps the channel, because here's the detail that matters for everything after this. A hurricane needs warm water. Push it over land or over a cold current, and it starves within hours. Earth builds monsters, and then Earth switches them off. Nothing else on this list has an off switch. Level 1. The fastest winds in the solar system. On the planet that should be asleep, Neptune sits so far out that it receives about 1/900th of the sunlight that reaches Earth. By every reasonable expectation, it should be a still, frozen, boring ball of ice. Almost nothing gets there to stir it. Instead, it has the fastest winds ever measured on any planet, around 1,200 miles an hour. If those winds happened here, they would outrun the speed of sound. They are not gusts, and they are not local. They are planet-wide jet streams, and they are powered from below. Neptune radiates roughly 2.5 times more heat than it receives from the sun, and nobody is entirely sure why. In 1989, Voyager 2 flew past and found a storm the size of Earth, the Great Dark Spot. When Hubble looked again 5 years later, it was simply gone, and a new one had appeared in the opposite hemisphere. The air out there sits at about 350 degrees below zero. It is also moving faster than anywhere else we know. Neptune's winds still blow across the planet, though. On the next one, the entire atmosphere has come loose. Level 2. The atmosphere that came loose. Weather that outran its own planet. Venus turns very slowly. One rotation takes 243 Earth days, which is longer than its year. Stand on the surface in a suit good enough to survive 900 degrees and 92 times Earth's pressure, and the ground under you is barely moving at all. Now look up. The clouds overhead are racing around the planet at roughly 220 miles an hour, completing a full lap every 4 days. The atmosphere is circling about 60 times faster than the planet beneath it. This is called superrotation, and we still cannot fully explain it. The result is a permanent storm system anchored at each pole. Enormous vortices, larger than Earth, that do not travel and do not dissipate. They just sit there, fed continuously by an atmosphere that has effectively detached from the surface. They are not even stable in shape. Venus Express watched the southern vortex morph from a tidy spiral into a chaotic, lopsided mess, and then reassemble over and over. On Venus, the weather is not really happening on the planet. It is sliding over the top of it. At least these storms are roughly round. The next one is not. Level 3. The storm with straight lines. The one that should not be geometrically possible. At Saturn's North Pole, there is a hexagon. Not roughly hexagonal, not hexagon-ish. 6 sides, each about 9,000 miles long, which makes every single side longer than the diameter of Earth. The whole structure spans around 18,000 miles. It is a jet stream, moving at about 200 miles an hour, and it has been holding that shape for as long as we have been able to look. Voyager found it in 1980. Cassini arrived in 2004, and it was unchanged. It is still there now. Laboratory experiments have produced the same polygonal patterns in rotating fluids, so this is ordinary physics. It just looks like the universe reached for a ruler. Sitting at the center is a separate storm, a hurricane-shaped vortex with an eye about 1,250 miles across. That is roughly 50 times the eye of an average hurricane on Earth, with cloud speeds at its edge around 330 miles an hour, locked in place at the pole, and it changes color with the seasons. Cassini watched it shift from blue to gold as northern summer arrived. This one has held its shape for decades. The next one has held for centuries, and it is finally losing. Level 4, the storm that is finally dying, Jupiter's Great Red Spot. This is an anticyclone, a high-pressure system which makes it the structural opposite of a hurricane. It rises above the cloud deck instead of sinking into it. Winds at its edge run about 280 miles an hour, driven by Jupiter's internal heat and by a planet that completes a full rotation every 10 hours. Now, the part most people still get wrong, you have probably heard that 3 Earths fit inside it. That was true in the 1800s. Today, the storm is about 14,000 kilometers across, which is around 1 Earth. It has been shrinking for over a century, losing roughly 560 miles of width every year. Its age has shrunk too. Cassini recorded a dark oval on Jupiter in 1665, and everyone assumed it was the same storm. A 2024 study compared the old drawings and concluded it almost certainly was not. That first spot faded out. The one we watched today has been observed continuously since 1831, which makes it about 190 years old, so it is not eternal and it is not what it was. There are children alive right now who may watch the Great Red Spot disappear. That is the worst our solar system can manage. Now we leave it. Level 5, where it rains glass sideways, and the glass is moving at Mach 7. HD 189733b is a gas giant 63 light years away, orbiting so close to its star that a full year takes 2.2 Earth days. It is tidally locked, so one face is permanently roasting at around 2000 degrees Fahrenheit. The heat is not the interesting part, the wind is. Air moves across this planet at 5,400 miles an hour, about 7 times the speed of sound and roughly 20 times faster than the strongest wind ever recorded on Earth. It blows from the scorching day side to the merely appalling night side in a permanent global storm, and the atmosphere is full of silicate particles, vaporized rock. On the cooler side, those particles condense into tiny shards of glass, which the wind then throws horizontally across the planet at supersonic speed. From a distance, it is genuinely beautiful. The silicate haze scatters blue light, so the planet is a deep cobalt marble. The color Earth is from orbit. NASA described the experience of being there as death by 1,000 cuts. Every storm so far happens inside an atmosphere. The last one happens to an atmosphere. Level 6, the storm that kills planets. And it is not made of air at all. When a star throws off a burst of charged particles, that wave travels out at millions of miles an hour. When it reaches a planet with a strong magnetic field, the field catches it and the particles spill down at the poles as auroras. That is what we get, curtains of green light and a good photograph. Mars had no such luck. Its magnetic field shut down billions of years ago when the core cooled, and the solar wind has been hitting the atmosphere directly ever since, stripping it away atom by atom. Maven has measured the rate, about 100 grams per second. That sounds like nothing. It is nothing on any timescale a person understands. Run it for a few billion years, and it is a planet losing the air that once let water sit on its surface. During solar storms, the rate jumps by a factor of 10 to 20. We have had one close call. In 1859, the Carrington event hit Earth with enough force that telegraph lines sparked and caught fire, and auroras appeared over the Caribbean. People read newspapers outdoors at midnight. The same storm today would take out power grids for months. And our sun is a quiet star. Red dwarfs, the most common stars in the galaxy, flare far more violently, and they do it at planets sitting right next to them. These are not storms anything rides out. They are storms a planet does not survive. So here's a question for you. Out of all 7 levels, which is the only storm that can ever run out of fuel? Drop your answer in the comments and tell me what I should explore next. Like, subscribe, and I will see you in the next one.